In this video, I'm going through Pythagoras on a grid, sometimes called the distance between two coordinates or the length of a line joining two coordinates. The question will give you two coordinates, usually not a grid, and it will ask you to find the distance between the coordinates, the length of the line as well. It will not generally mention Pythagoras. But let's have a look at this grid and the two coordinates A and B. So A is the coordinate 1, 1. Remember, the first number is x, the second number is y, and I'm going to call this x1 and y1 because they are the x and y belonging to the first coordinate. And I'm going to call this x2 and y2 because they're the x and y coordinates belonging to the second point on the grid. Now, the question says, find the distance AB. Well, the distance AB is the distance of this line or the length of this line. Now, I can create a right-angled triangle, and you can see that AB, this coordinate, is the hypotenuse. And these coordinates are always the hypotenuse. They're not vertical or horizontal, they're diagonal lines, and they will always make the hypotenuse. So the distance, the horizontal or x distance, starts from 6, which is this coordinate, and ends at 1, which is that coordinate. So it's really a 6 minus 1, which is a distance of 5. And then the vertical distance, that's a very bad vertical line, the vertical distance, which is the y distance, starts with y is 9, which is this one, and ends with y is 1, which is that one. And therefore, this distance is 9 minus 1, which is 8. So what do I do to find AB? Well, I do the square root of 5 squared plus 8 squared. And I put that onto my calculator, square root of 5 squared plus 8 squared. And I press my SD button, and to, let's say, 3 significant figures, it's 9.43. That's the length of the line. Now, how does this translate into a formula? Well, I basically did x2 minus x1 to get the distance, and then I squared it. So I squared x2 minus x1, and then what I also did for the vertical distance is I got y2 and I did minus y1, and I also squared that, and I added them because I'm always finding the hypotenuse. So the formula, when you are given two coordinates, so you're given two coordinates, x1 and y1, and x2 and y2, the distance or the length of the line is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now make sure that you are subtracting the x from the x. So x from x, not x from y. And then you're also subtracting y from y. The order really doesn't matter, and I'll show you why. If you have 5 minus 3, that's a 2, a positive 2, squared is 4. If you reverse it, and if you do 3 minus 5, that's a negative 2, but when you square a negative number, it also gives you a positive 4. So actually the order with x2 and x1 doesn't matter in this context. But because of other contexts like the gradient, y2 minus y1, x2 minus x1, I would always just keep the order the same. So I would make an effort, because it will make a difference in this context, the order that you use. So I would just keep the order the same. x2 minus x1 plus y2 minus y1, both of them are squared and then square rooted. So this is what a question would look like. Coordinate A is 6, 2, coordinate B is 8, 5. Find the length of the line AB. So this is x1, y1, x2, y2. So AB is the square root, and it's 8 minus 6 squared plus, always a plus, 5 minus 2 squared. And I'll get my calculator and I'll put that in exactly how I see it. Square root 8 minus 6 brackets squared plus 5 minus 2 brackets squared equals, and it's root 13. So if they want the exact answer, you give root 13, so that's the exact answer. And if they want it to 3 significant figures, you will press your SD button, and this is 3.61 because the 5 rounds the 0 up. 3.61 to 3 significant figures. And we'll do one more. Calculate the distance between these two coordinates, x1, y1, x2, y2. So the distance is going to be the square root, and it is negative 2 minus 3, x2 minus x1 squared, plus 5 minus 7 squared. And again, I'll put that into my square root, minus 2 minus 3 squared, plus 5 minus 7 squared, and it's root 29, and that is 5.39 because the 5 rounds the 8 up. So 5.39 to 3 significant figures. And that is the end of Pythagoras on a grid.